For this lesson, we're going to be looking at all of the ratios we were doing yesterday, but we're going to be looking at them for angles above 90 degrees. So let's begin with some definitions. So an angle theta in the Cartesian plane is located in quadrant 1 when its vertex lies at the origin, right here, and its initial arm, the arm that's fixed, lies on the x-axis here. Now our angle theta is measured from the initial arm to the terminal arm. And that's the arm that rotates. So the way to think of it is my terminal arm starts at my initial arm and then increases up kind of like an alligator mouth until we get the angle that we're looking for inside here. And that terminal arm will get wider and wider and wider, and the little alligator mouth will get bigger and bigger and bigger, giving us a bigger angle or a bigger theta. So up until this point, you've always looked at angles in quadrant 1 for a triangle, but now we're going to expand out of quadrant 1. So there's a few more important definitions that we need to know when we expand from quadrant 1. So the principal angle is the counterclockwise angle between the initial arm and the terminal arm of an angle in standard position. And its value will always be between 0 and 360. So again, in this diagram, I have my initial arm right along the x-axis, and then I have my terminal arm. So picture my little alligator mouth opening really wide, and it opens so wide that his head tilts back. And that angle that our alligator is making with its mouth is called our principal angle, that theta that's in the middle here. Now, the acute angle between the terminal arm of an angle in standard position and the x-axis is where the terminal arm lies in quadrants 2, 3, or 4. And it is called the related acute angle. So if I look here, this big red line is a very obtuse angle. My alligator has his mouth really wide open, and that red angle is a very obtuse angle here. Now, this little angle that's living over here is called my related acute angle. So if you look at here, the reason it's related is it's because it's what's left for this to get fully flat on the other side. So that's my related acute angle, and that is often denoted by a beta. So we'll be drawing a lot of those as well. Next, we can also have a negative angle. And this is an interesting thing to think of because we usually think of our angles always opening to the left or counterclockwise. But if I have an angle going clockwise like this, that is called the negative angle. So again, we're still starting from our initial arm here, but instead of opening the way we usually do, we're going to go backwards and get to our terminal arm over here. And that would be a negative angle. So that negative sign is just telling you the direction that your arm is moving. So in this section, we're going to be using the Cartesian plane to evaluate our primary trig ratios for angles between 0 and 360. So we're not just going to look at things that are less than 90, we're going to continue on to look at some bigger angles. So we're going to do a bit of an investigation to start, and because we're not in class, we'll have to do this investigation together. So the first thing we're going to do is we're going to plot the points on the grid and we're going to draw the terminal arm. So let's start that for A. So we'll make A green. and we're going to plot that point on the grid, and we're going to draw the terminal arm. So A is at 3, 1, 2, 3, 4. 3, 4 right here, and that's A. And we're going to draw our terminal arm. So there's the end of my angle. And remember, our initial arm for all of them is going to be right here. So my A goes from my initial arm and opens up to here. So the angle that's formed by that point A is this angle on the inside here. And we're just going to call that angle A. Now the next thing we want to do is we want to find the length of that arm using the Pythagorean theorem. So that's what we're going to do. So we're just going to have my arm here go straight down like this. And that means that we have, I'll get a darker color so you can see it, 3 on the bottom, 4 here. So if I use Pythagorean theorem for that, I'm going to have 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. And we will get 25 equals c squared. And we'll square root both sides, so we'll get 5 equals c. So this value here is 5. Next, we're going to find our sine. Actually, I'll put an A there. Our sine, our cosine, and our tan for that first one. So sine is opposite over hypotenuse, so we will have 4 over 5. My cosine is adjacent over hypotenuse, so we'll have 3 over 5. And my tan is opposite over adjacent, so we'll have 4 over 3, like this. And then we'll circle which ratios are positive. So just because I think circling will be hard for you guys to see, I'm just going to highlight all of the positive ones. So there is our first one, A. Now let's do B. So B is at -3, 4. So let's draw out that terminal arm here. There we go. Just like that. And we're going to be looking at the related acute angles here. So when we're doing this, we're always going to look at the related acute angles for this whole investigation. So here's B. And now we need to find the length of the terminal arm using the Pythagorean theorem. So this bottom is 3, and here is 4, like that. And now let's find our values for B. So we'll start doing our Pythagorean theorem. So again, we'll have 3 squared plus 4 squared equals c squared. So we'll get 5 here again. And that's going to be consistent for all of them. So we don't need to keep doing that over and over. So now if I look here, I'll find my sine of B, and that will be 4 over 5. And now my cosine of B, I'm going to have -3 over 5. And the reason it's negative is because this 3 here is going in the negative direction. So see how my 3 over here is negative? Because it's going in the negative direction, we're going to account for that in our ratios. Now we have tan of B, and that's going to be opposite over adjacent, so we'll have 4 over -3. So now our last step was to highlight the positive ones, which is just this one. Okay, now we have C. So C is at -3, -4. There we go. And we're going to look at our related acute angle again, C here. Then we use Pythagorean theorem to find the lengths. So the lengths will be the same. And now we'll find which lengths are negative. So this side is going down towards our point, so it's -4. And our top side is still -3 because it's on the negative axis. And then here we have 5 as our length. So now for C, let's find all of our ratios. So sine of C is going to be -4/5. Cosine of C is going to be -3/5. And tan of C is going to be -4/-3. And a negative divided by a negative is positive. So now the last step is to highlight which one is positive. And our last example here, we're almost done. So we'll do D now. So D is at 3, -4 right here. And I will draw my terminal arm. And then we'll have our little related acute angle here. Connect it. Now we would find our length using the Pythagorean theorem, but we've already done that, so there's no sense in doing it again. So I know that we'll have -4 here, and we will have +5 over here, and then we still have +3 here from the beginning. So now we have sine of D is going to be opposite over hypotenuse, so we'll have -4/3. Cosine of D is going to be adjacent over hypotenuse. Sorry, that should have been a 5. And finally, tan of D is going to be opposite over adjacent, which is -4/3. And finally, we highlight the ones that are positive, which is just our cosine here. So what I want you to take note of is which ones are positive in each quadrant. So let's sum this up down here. So in quadrant 1, if I look which ones are positive, all of my ratios were positive in quadrant 1. If I look in quadrant 2, only my sine ratio is positive. If I look in quadrant 3, only my tan ratio is positive. And if I look in quadrant 4, only my cosine ratio is positive. Now we have a little acronym to help us remember that, and it is called the CAST rule. So I start here. I have C for cosine, A for all, S for sine, and T for tan here. So that is our CAST rule to help you remember where my angles are positive in different quadrants. So again, called our CAST rule, and then we use our CAST rule to determine the sign of our trigonometric ratios. Our next step is to start finding our related acute angles. So when we find our related acute angles, we want to keep in mind our special angles from our special triangles earlier. And those were 30 degrees, 60 degrees, and 45 degrees. So we want to find all of the angles that have related acute angles just like this. So let's start in quadrant 1. So in quadrant 1, my angles are just my special angles. So I have 30 degrees, I have 45 degrees, and I have 60 degrees. So I'm just labeling those because if we know our special angles, we know their exact values. And now we can use those to find exact values of many different angles in different quadrants. So let's go to quadrant 2. So when I measure a related acute angle, I'm always measuring from the x-axis. So over here, I'll start with my 30-degree one. So here I would have a related acute angle of 30 degrees. So if I think about what this big angle must be, it would be 180 minus 30. So that big angle would be 150 degrees. So to get from 0 to get all the way over here and only have 30 left to get to 180, that must be 150. Next, let's look at our second one, which would have a related acute angle here of 45 degrees. So if I think of what that big angle is, I go from 0 all the way over here, and I have 45 left, so that would be 135 degrees. And our last one, so if I think about this, I have a related acute angle of 60 degrees. So my big angle would go from 0 to the terminal arm and have 60 degrees left to get me to 180. So that would mean that this angle is 120 degrees. Now let's try quadrant 3. Again, remembering that we always measure our related acute angle from the x-axis. So let's start with our 60 related acute angle. So from the x-axis, we have 60 degrees. So I want to think about what that big angle would be all the way to here. Keep going 60 more. So that big angle must be 240 degrees. Now let's do our 45-degree special angle. So if my related acute angle from the x-axis to my terminal arm is 45, this giant big angle here would be 225 degrees. And our last one in quadrant 3, so our last one has a related acute angle of 30 degrees. So if I think of the big angle, I went from 0 all the way around past 180 and an extra 30. So that one is 210 degrees. All right, last quadrant, we'll move on to quadrant 4. So again, we remember that our related acute angles are always measured from the x-axis. So we'll start with our 60-degree one. Sorry, these aren't super accurate. 60, I guess, would be more like here. So we have 60 degrees from the x-axis. So how big would that angle have been for me to go all the way from 0, all the way around, and get to a point where I only have 60 left to complete the circle? That would give me 300 degrees. Now let's look at our 45-degree one. So we have 45 degrees left. That's our related acute angle from the x-axis to our terminal arm. Now I want to think, what would my angle have been going all the way from 0 all the way around to the terminal arm? That angle would be 315 degrees. And now let's do our last one that has our related acute angle of 30 degrees. So I went all the way from 0, went all the way around, and then only had 30 degrees left to get to a full circle. So I'll have 330 degrees. So those are all of my special angles, the ones that we can find exact values for. So now let's go through and I'll show you how to find the exact values. So we have 4 main steps. So let's start with example A, and we're going to be referencing these steps over and over so that we can include every step every time. So for A, the first thing we do is we draw our angle of rotation. So let's start there. I'm just going to draw a little sketch. So remember that we have 0, 90, 180, 270, just to help orient yourself. So for A, we're looking at cosine of 315. So 315 starts here, passes 90, passes 180, passes 270, and is going to end up somewhere around here, being our terminal arm. That's the first step. The second step is to find our related acute angle. So my related acute angle is always the angle from the x-axis to my terminal arm in there. So if this is 315, how much do I have left in here to get to 360? That means inside here, my related acute angle is going to be 45 degrees in there. That's what's left between my terminal arm and the x-axis. Now, let's use our special triangles to figure out our exact value. So, we're going to start by looking at our special angle. So, we're looking for cosine of 315. So, we're going to start by looking at cosine of our related acute angle. We're going to start there. So cosine of our related acute angle is cosine of 45 degrees. Now, if we think back to our special triangles from yesterday, that is one of our special angles. And cosine of 45 is root 2 over 2. So now the last step is we need to use cast rule to determine the sign of the trig ratio. So remember our cast rule, C, A, S, T. So in quadrant 4, cosine is positive, so I don't need to change the sign. So I can just say that my cosine of 315 it's positive because it's in the 4th quadrant, root 2 over 2. And that would be my final answer. Let's try another one. So for B, B is sine 210. So the first thing we're going to do is we're going to sketch that angle. So I'm just going to draw a little Cartesian plane. And let's sketch the angle 210. So I start at 0. I'm going to go past 90, past 180, and then stop at 210. Now I need to find my related acute angle. So remember, my related acute angle is always measured from the x-axis. So it's living right in here. And the difference of 210 to 180 is 30 degrees. So we have 30 degrees in there. So now I'm looking for sine of 210. So I'm going to start by finding, sine of my related acute angle. Because it's related, it's going to have the same value. The only difference is the sign, and we will use cast rule to figure that out. So we have sine of our related acute angle, which is 30. And that is another one of our special angles. So sine of 30 is 1/2. So now I use my cast rule to figure out the sine. So we have CAST. So because we're living in quadrant 3, sine of 210 is still going to be the same number as my related acute angle. The only difference is it's going to be negative because it's living in quadrant 3. Now, let's try example C. So for C, we are looking for tan 300. So we're going to start by drawing out a diagram. And now let's draw our terminal arm. So it's at 300. So we always start here. We're going to go past 90, past 180, past 270, and get to 300. Now, in order to figure out what our value is, we need to find our related acute angle. And remember that our related acute angle is always measured from the x-axis. So the difference between our full circle 360 and our terminal arm at 300 is 60 degrees. So we're looking for tan 300. So we're going to start by looking at tan of our related acute angle. So that will be tan 60. And that is one of our special ones. So tan of 60 is going to be √3. So now we know the value. We now need to figure out the sine. So I look at my cast rule. Oh, sorry. So we have CAST. So because this angle is living in the fourth quadrant, in that quadrant, only cosine is positive. So I know that tan of 300 is the same as tan of 60. But because it's living in the fourth quadrant or the C quadrant, it doesn't get to be positive, so it's negative √3. I might write that a little bit nicer. Negative √3. All right, one more example. So for D, we're looking at cosecant 120. So let's start by drawing out 120. Start here, go all the way around, past 90 to 120 over here. There we go. So because we don't have special values for cosecant, we're going to use our special values for sine, find sine of 120, and then we can find cosecant after that. So let's start by finding sine of 120. So we have 120 here. Now we need to find our related acute angle, which is always measured from the x-axis. So the difference between 180 and 120 is 60 degrees in here, like that. So let's start by finding our sine of our related acute angle. So that will be sine of 60, and sine of 60 is going to be √3/2. Now, what we want to find is let's find sine of 120. So we still know it's √3/2. The only difference now is the sign. So I look at my cast rule, CAST, and it's in the sine quadrant, in quadrant 2, where sine gets to be positive. So we don't need to change the sign. It can just stay as positive √3/2. But the question didn't ask for sine, it asked for cosecant. So when we have cosecant, we flip our sign. And we don't like having radicals on the bottom, so let's get rid of that. So cosecant 120 is going to be 2 root 3 over 3. And that is our final answer. So those are the steps that we'll use continuously to find our values. Okay, let's do one more example here. So if point P is at -5, -8, and it's on the circumference of a circle, we want to determine the primary trigonometric ratios for the principal angle. So what we're going to do is we're going to start with a diagram. There we go. And I'm going to plot -5, -8. I'm just going to draw a quick sketch. It's not going to be pretty. And I'm looking for the primary trigonometric ratios for the principal angle. So remember, my principal angle is that whole angle. So let's start by using our Pythagorean theorem in order to find the lengths of the sides of our triangle here. So we have -5 here, -8 here, like this. And now we're going to use Pythagorean theorem to find our hypotenuse. So we have a squared plus b squared equals c squared, 5 squared plus -8 squared, c squared, 25 plus 64 equals c squared. And we'll have 89 equals c squared, so root 89 equals c. So now we have that root 89 is our c. So now let's find our ratios. So we're going to have sine is opposite over hypotenuse. So of my little related acute angle here, my opposite is -8 all over root 89, which is my hypotenuse. Now for cosine, we have adjacent over hypotenuse, so we'll have -5 over root 89. And finally, tan is opposite over adjacent, so I have -8 over -5, but a negative divided by a negative is positive. And just for right now, I'm just going to leave those radicals on the bottom. Don't worry too much about it. It's just the principle of us really understanding the cast rule. But the last thing I want to do is I just want to double check the signs on all of my ratios to make sure I didn't make any mistakes. So I have my cast rule. So because this is living in quadrant 3, only my t should be positive. And if I look, sine is negative, cosine is negative, and tan is positive. So we've done everything correct. So now there's a few below for you to try. Follow the exact same steps that we did, and I think that you'll be able to pick it up quite quickly.